Hi, it's me, I'm Nafith. Today I will talk about how the pre-shared key or PSK tunneled SSID in Aruba OS 10 using Aruba Central to manage it, how it works. So we have the client, we have the access point, obviously physically these AP and mobility gateway connected physically somehow, and they are able to reach each other. Tunnel will be established. Now the control plane tunnel, which is IPsec tunnel, this is where the authentication request goes through. So the request will have some information, one of which will be the station ID. Calling station ID is the MAC address of the requesting client. And then once everything works, this is the authenticator, and this is the radius proxy. And the request assume that will be sent back to the authenticator to indicate what to do. So which VLAN does the user end up with? VLAN 20 in this case. That VLAN 20 is configured on the mobility gateway, but not on the switch interface facing the AP. It is a tunnel VLAN. And then the user connect, and then the traffic will be sent with the tagged VLAN. And there we go. The client now has performed the pre-shared key authentication. So let's look at some details and then we'll proceed in this video. So now we have the groups created. So the gateways, they are their own group. We look at devices. So we have these two gateways, and the access points, they are in their own group. You will notice these are the two APs. So we're going to create a WLAN, but we will show you the pre-shared key way to do it, as well as later on we will look into the enterprise one, which is .1x. And both of these WLANs will be tunneled, i.e. the traffic or the user traffic will be using overlay tunnel to reach the mobility gateway, and then that mobility gateway will take the traffic, tag it, and send it to wherever the destination should be going to. So we are on the AP group, campus Wi-Fi. We're going to create a new SSID, and for simplicity I will give it a name Nafith pre-shared key. Next, and it's going to be tunnel. Of course, the cluster has already been created, and we're going to look at where is the cluster that will communicate, what cluster will be used to communicate in this case. So the list is populated now. We will use our cluster, and there's no secondary cluster as a backup. We're using two gateways in one cluster. These VLANs that we're going to see a list of VLANs, you could create one here, but we created one before, which is simply speaking the employee VLAN. We can look into this, and that VLAN exists on the switch interface. So if you have any other VLAN, you can select any other VLAN. You could also create the VLAN there and then. So this create a VLAN rather than using one, because we'd like to use a different VLAN. So we click on show name VLAN, and we can add a new VLAN. Now that VLAN, when it gets added, it will be populated into the gateways themselves. So IoT, we just represent as if this is IoT, and VLAN 34. Now before we do this, we'll double check the gateway VLANs. If they have the VLAN 34, which they don't right now have that VLAN, that will be created thanks to the wizard. Thanks for the wizard we are using here. So VLAN 34. So if we, on one of the gateways, show VLAN, VLAN 34 doesn't exist. It will be created by the fact that we are using the wizard to create the WLAN. You could have pre-created it before if you wanted to. So now in the VLAN list, we can see a new VLAN has been created called IoT VLAN. So now this is one of the VLANs that have been created. We go next. Remember that VLAN doesn't exist on the access point or doesn't exist on the switch where the AP is connected to. You cannot do that. That's as per the specifications for Aruba OS version 10. Now we will pick up the password. whatever password you select. For the firewall, we'll leave it as is, and we will review summary here, and then we finish the creation. It has now been created, and you can see a list. That's the only one now available in this case. Let's look at the audit trail here, and we will see that something has been done, created, updated WLAN profile pre-shared key. Click on this, it will show you the commands that have been pushed by the wizard for WLAN creation. Also overlay WLAN SSID cluster mapping. So this is to show you the tunnel that has been created in this case. So just to ensure that what you have created or configured has been pushed is extremely useful to go to audit trail. One of the areas you need to visit quite often. So if you go back to this, you can clearly see this is the pre-shared key operation mode WPA3, and then the WPA passphrase, detail of all the entries and the for example rules here, firewall rules that are part of this WLAN. If you look at the configuration on the gateway updated, this one of the other entries, so you can see that the config ID updated is to 14. It means a new config has been added. Transaction ID, the configuration, that's the path inside the campus gateway. That's MD, the old style MD, which is managed device campus Wi-Fi group, that is part of that. Now we look at the VLAN that was created. We should expect a VLAN, show VLAN now. A new VLAN that was added, VLAN 34. That's a VLAN 34. And show VLAN mapping. You're going to see that the name of that VLAN is IoT. These other VLANs we created them beforehand on the actual group where the gateway belongs to. We need to look at the users. So in this case, I looked into because there are two gateways, it's possible to be tunneled to one of these gateways as a main gateway. And on this gateway one, if you issue the command show user, I don't see. And we can issue the command show user standby. It will show you the user, and that's a VLAN. The layer 2 role, that's the default role, will be the same name as the SSID and pre-shared key. And they will give us details of ESSID, which is the human readable name. BSSID is the MAC address of the radio where it is connected to. It is a tunnel, and the active user anchor controller IP, which is the secondary controller. You can see 10.1.3.22, because this one is show IP interface brief. This one is 21. So if we go to the other controller and we can see show user, you're going to see the user is listed here. Of course, you can look at more other details. The username, because this pre-shared key is equal to the MAC address of that client. That's the name of the user always. As I said to you, the role is the name of the pre-shared key SSID connected to that access point. So 8C10. Let's go to Central. Sometimes it takes a bit of time to update the user list here. Has not yet updated it. We can go to global and see if that user, now it's been updated. Actually, it's only updated the gateway. We'll come back to this. Yeah, this is the role, actually, gateway role tunneled. That's the one, and that's the user itself. If you click on that user, you're going to see the user connected, and this is not updated yet, because that will show you tunnel between the client and the gateway. because we manage the access points and we manage the switches, this data path will be updated. But in short, this is the client, and we will come and revisit the client again. But the key point is when you go to the gateway, you see the client listed in here. We can go to Central, and we can go to the access point in this case, and actually the group where the access points belong to. These are the two access points, and the serial number, and there's a firmware, and obviously AP1. That's the AP1. That's the MAC address of AP1. AP2. Again, central interface has not updated not been updated in terms of the client list. We don't see the clients as yet. So we're gonna wait a little bit, but we know the clients do exist. If we go to the access point console or SSH to the access point, you're gonna see with the command show client, you can see the client listed on that AP. We'll show it to you now. So that's the AP, and we can issue the command show client. We can see which client is connected. That's the pre-shared key, SSID. It's Windows 10 the client, and the MAC address of that client, and the IP address of the client, and the name, as we said, because that's confirm MAC authentication pre-shared key. And then we have the MAC address equal to username, and access point AP2. The channel is 100E. It means it is 802 or 5 gigahertz at least, and it's AC. And then that's a role, and that's IPv6 address, signal 61 good, and the speed is 650 megabit per second. And these are some details of the client that is connected to that AP. So if we look into the tunnel, because there's a tunnel now between the access point and the gateway, and we are on the access point, show crypto IP6 stats. We can see the tunnel that has been from two tunnels, one being active, one being standby. The active one, one of them goes to the gateway 1, and the other one goes to the gateway 2. These are two different tunnels. Basically, that's tunnel 0, which is the one that is configured. And we can look at the access point tunnel agent, show ATA current config. We're going to see that the current state is up, central, so the connection to central is up. And inside the list for primary, this is the one we connected to. So this is the one that the client is connected to in this case. And we can look into also another command, show ATA endpoint. We're going to see this will show us the tunnels and the state of that tunnel, and we can see a state is connected, two tunnels, one being primary, which is the top one, and the one being standby, which is the bottom one. So should one gateway go down, then that will be compensated by the other tunnel. Notice the GRE VLANs. These are the tunnel VLANs using the GRE. These are the user VLANs that could use. Of course, none of these VLANs should be visible to the AP. These are tunneled VLANs. These are tunneled VLANs. If you go to the gateway itself where the client is connected or tunneled to, show crypto IPsec security association, it will show you the SA information. So connectivity, initiator IP, responder IP. So this is the tunnel between the two gateways, and you find also the tunnel between itself and the two access points. And you can see T2 means this is a tunnel IC version 2, and UTLT, this is tunnel based on UDP. So these are the GRE tunnels, and this is the IP6 tunnel between the two gateways in this case. Of course, that shows us clearly that there are tunnels between the access point and and the gateway based on the fact that we have created a WLAN that is tunneled. We can issue the command show crypto ISA KMP, which is phase 1. You can see also again, remember this is something between the two gateways. Again, this is as the stage where the negotiation of the keys. So this is inside the cluster itself. So they are able to communicate and form a full tunnel. And there are some other commands you can issue as well. Remember in version 10, Aruba OS 10, the access point will decrypt the traffic received encrypted from the client. So to send it out on a GRE tunnel unencrypted, you can apply what's called IPsec. So then that would be GRE over IPsec. If the if tunneling unencrypted is not really accepted, then we can encrypt the traffic in that tunnel. We will do this, and I'll show you how to do that. So we go to the group where the APs belong to, and this is and then we go to access points here. In this case, we can go to security if you would like, and in security we can scroll to data handling. Discard. Yeah, so in security, data handling by default is turned off. Data encryption is enabled now, and we can save these settings. Basically, do these settings from the access point group true, but will be pushed by the cloud over tunnel or overlay tunnel orchestration service (OTO). It will instruct both the AP and the gateway to establish a GRE tunnel over IPsec instead of just only GRE tunnels. Now, if we go back and double check the obviously, if you look at the audit trail, you will see we push some config here, updated, and it will show you what we have updated here. In the profile, we talk about the configuration overlay, SID cluster, and then this is the profile, and then we have updated tunnel type GRE over IPsec tunnel. So that has been updated in this case. Now, if we double check the configuration on the AP, so we go to AP now, which is AP2, and we issue the command show ATA, AP tunnel agent, current config. We're going to see that tunnel type GRE over IPsec, the tunnel type GRE over IPsec, and we can issue the command also show ATA endpoint. Now we're going to see that has changed from only GRE in the previous case to GRE over IPsec. Compare this one to the older one. This is the older one without encrypting the tunnel. So we have GRE over the IPsec tunnel. So rather than just having GRE on its own unencrypted, you're going to see that it's encrypted now. We're going back to client, so now they show up, and the client we're talking about is wireless, this one. It is connected. If you click on it, you'll find the overlay tunnel and the switch. Since the switch as well as gateway and AP, all of these three entities are managed by Central. You can see them connected, physical connectivities, and then this is the virtual, which is overlay tunnel.